Okay, so this is problem 10.22C. All right, and the thing they're asking for is the same directions as the one we just did. So rewrite this as a matrix equation and then verify that this proposed y solves this thing. So in order to rewrite as a matrix equation, I think I need to say something like, all right, so y prime is equal to, and then I need the coefficient matrix here. So how do I get that thing, guys? Okay, cool. So you get, oops, shit handwriting. Minus 1, 2, 2, 2 minus 1, 2, and 2, 2 minus 1. Just literally pulling the numbers straight out of there. And then I need a y outside. Right? So this is my differential equation written down in matrix form. Then I really need to write y in vector form. Right, so y is a vector, and it should be made out of a minus c1 e to the minus 3t. Let's see. Thankfully, there's no the c2 times 0 part. So I get plus c3 e to the 3t. Then my next row has no c1, so I get minus c2 e to the minus 3t plus c3 e to the 3t. And then last one, I get a c1 e to the minus 3t plus c2 e to the minus 3t plus c3 e to the 3t. And then if you were paying attention for our last discussion there about eigenvalues and vectors, you might notice that that means that I was supposed to have eigen pairs, right? And so if I'm looking at this thing and thinking about those eigen pairs, apparently they look like minus 1, 0, 1, minus 3, 0, minus 1, 1, with minus 3, and 1, 1, 1, with 3. And maybe you notice that something's a little bit weird, that minus 3 is in here twice. Does anybody remember how that can happen? Oh my god, today with the microphones. I have no idea. Nothing has changed about this setup that I'm using. We'll try. How about that? Can you guys hear me still? Okay. Good deal. Yeah, I don't. Maybe it was on auto, so maybe it got put back to auto and it was on manual before. I don't know. We'll try it this way. If it cuts out again, let me know and I'll throw my computer out the window and we'll call it a day. We can all do that. I mean, yeah, we can quit. I wouldn't recommend it. You guys are almost done with the course. Yeah. Both. Being bored and anxious is the worst. Yeah. The state I'm in today, today I have a snail on my desk because it was in the street and I felt like I should save a life if I could. And also I read on the internet that you can hear them chew, so I have to hear that. I have to wait for him to come out of his shell to tell me. Yeah. Lettuce. I don't know. I named him Sam Cargo. So he would be referred to as Mr. S Cargo. Okay, at any rate, I'm supposed to be verifying that this is a solution, right? So to get one of the sides, what can I do? Yes, I can prime the y. So y prime is, let's see, 3c1 e to the minus 3t plus 3c3 e to the 3t and 3c2 e to the minus 3t plus 3c3 e to the 3t and minus 3c1 e to the minus 3t. I apparently lost a t in one of those. Wait, what? Oh, yeah, sorry. I didn't put zeros in here. If they had been in the matrix, I would have put them in the matrix, but they weren't in the vector, but I didn't put them in the vector because I'm lazy. So then on the bottom, right, I have minus 3c1 e to the minus 3t and minus 3c2 e to the minus 3t and plus 3c3 e to the 3t. Okay, so that thing there is my left-hand side, supposedly. And now I have some kind of semi-horrible multiplication ahead of me. So I'm going to get a vector, and it's going to have 3 rows in it. And this first row is going to be row 1 dotted with y. And then the second row is going to be row 2 dotted with y. And then the third row is going to be row 3 dotted with y. And I guess I'm saying that they're rows, but really all they're going to be is a scalar function. They're just going to be really long. So my first... What's that? Yeah, this stuff actually is one of these things that's this is thankfully one of the things at the end of the class, and I like to do this stuff at the end of the class because it is both a little bit easier conceptually and a little bit easier algebraically. And this first section where you verify things is the worst of the calculation stuff. So even though this right now is kind of algebraically annoying, this is as bad as this gets, which is definitely better than everything else has been. I mean, this is conceptually, this stuff is as easy as anything else in the course. So this is really like a nice return back to the chapter 1, like, oh yeah, you just find the constants and then it's easy. So multiplying, I have minus 1 times the top thing. So that's minus 3c1. Oops. Nope, it's not. I'm doing times y, right? So that's this thing that I need to be using. So that's minus times minus c1 e to the minus 3t plus c3 e to the 3t plus 2 times minus c2 e to the minus 3t plus c3 e to the 3t plus 2, and then I need my third thing, so that's c1 e to the minus 3t plus c2 e to the minus 3t plus c3 e to the 3t. Because, yeah, this is one of those things that in the series section and in this section, people often write landscape style on their papers. Like I said, thankfully this is the last time it's this bad, because the rest of the time what you do is you just find the eigenvalues and then find the eigenvectors, and then you just plug them in. So it's, thankfully, like, executing this isn't that hard. It's just verifying the solutions are a little tedious. And if we were willing to kind of use the superposition principle, this would be a little bit easier, because then we could verify that the first part was a solution, and that the middle part was a solution, and that the third part was a solution, and then we just assume that when you add them all three up, you get a solution. Does that make sense? And if you guys want to do that on your homework, I'm okay with that. But for right now, for just demonstrating this, I'm going to do the whole thing. So where do I get my second row from? From the place. Yeah, so take the second row, so that's 2 minus 1 plus 2, right? And then I just need to write these same things in there, because I'm multiplying by the same factors. So that's going to be minus c1 e to the minus 3t plus c3 e to the 3t minus c2 e to the minus 3t plus c3 e to the 3t, and then this whole thing of c1 e to the minus 3t plus c2 e to the minus 3t plus c3 e to the 3t. And then in the last row, I have 2, 2, and minus 1 are my coefficients. And then we need to write the same stuff again. I wonder if I can just do this. Oh, sick. Damn it. What's what on the right hand side of the screen? Shit. What? I'm so confused, buddy. Are you having a stroke, Adam? Did you guys know that works in all the grocery stores? When they ask you to put in your phone number, yeah, someone has signed up at every single grocery store with that number. Also the all zeros always works. Okay, so point is, I should be able to now stick all these things together, right? Combining like terms. So I'm going to go through and find the e to the minus 3t's. So there's some, there's some, there's some, and there's some, right? Okay, so, oops, that's not a pen. Okay, so that first one is a c1 e to the minus 3t. That's positive. Then I have a minus 2 c2 e to the minus 3t. And a plus 2 c1 e to the minus 3t. And a plus 2 c2 e to the minus 3t. Some of that cancels. That's good. Then I have, I should have terms for should have terms for e to the 3t's. So that's these guys. And there's minus c3 plus 2c3 plus 2c3. And all of that was times e to the 3t. No. How would a Valley Girl solve this problem? That is awful. Awful. Yeah, you should say mate. Let's see. Okay, so second row, e to the minus 3t's. E to the minus 3t's. I have minus 2 c1 plus c2 plus 2 c1 plus 2 c2. Then second row second row e to the 3t's. I have a plus 2c3 minus c3 plus 2c3. That's e to the 3t's. Then third row on the minus, or e to the minus 3t's, I have, let's see, minus 2c1 minus 2c2 minus c1 minus c2. And then for the regular e to the 3t's, I have 2c3 plus 2c3 minus c3 e to the 3t. And if I combine like terms through that, I have all told here, I'm moving back up here so it can be in a spot that I can see my y prime. So all told there, I got a 3c1 e to the minus 3t plus 3c3 e to the 3t. Then in the second row, I have some c1s cancel, so I have 3c2 e to the minus 3t plus 3c3 e to the 3t. And then in my last row, I have a minus 3c1 e to the minus 3t minus 3c2 e to the minus 3t and a plus 3c3 e to the positive 3t. And that's the right-hand side is supposed to equal this. So all told, I have the let's see, the left-hand side and the right-hand side match. Cool. So this indeed solves this thing. I've gone through the process and verified that this is a solution. Questions, things? Yeah, let me go look in the directions. So directions say rewrite the system in matrix form. Okay, I did that. That was kind of this part. Rewrite into matrix form. Okay. Verify that the given vector function satisfies the system for any choice of constants, C1, C2, and C3. And in fact, this works with the constants in it, right? They're not saying pick constants, they're saying leave the constants in there. Okay, so this whole rigmarole, this loop here, and then getting that this thing actually equals that thing, that's the verify part. So because those are the same, I verified that the left-hand side equals the right-hand side, and thus y is the solution. Does that make sense? Okay. If you want a snip of this, take it fast.